For a lot of us, mathematics feels, well, untouchable. It's abstract, maybe even a little cold. But today, we're going to talk about how to change that, how to transform math into something physical, something you can actually hold in your hands, and because of that, something you can finally, truly understand.
I mean, think about it. When you first learn math, it's almost always in this super quiet internal world. It's just you and the problem on the page. It exists as all these symbols, a language of formulas that can feel so far away from our real day-to-day lives.
And that feeling, it creates this distance, right? For so many people, this is where the connection to math just snaps. It feels like something that only exists in your head, not in the actual world. But what if we could just shatter that silence? What if we could pull math right off the page and into our hands? Well, this is where a really profound transformation starts to happen.
So the core idea here is incredibly powerful, and it's this. The act of making something is one of the deepest ways to learn. We're about to see what happens when you stop just memorizing geometry and you start building it.
And it all starts with something so simple, a physical act. You just pick up a sheet of paper, you fold it once, maybe twice, you get those edges lined up perfectly. Then, with just one single cut along a line, something amazing happens. A shape just emerges. Not one you drew, but one you literally built. And this is what we mean by creative power. You're not a passive student of math anymore, you're an active creator. Every single fold you make becomes an angle, every edge becomes a theorem. You are, quite literally, building proofs with your hands. Now, the really cool part of this whole process is that aha moment. You know the one. It's that flash of insight where your mind just gets it. Not because someone told you the answer, but because you experienced it. The creation itself becomes the understanding.
Okay, so you've built your model. The act of creating it has already sparked something in your brain. But the lesson isn't over, not by a long shot. Now, a whole new kind of truth starts to reveal itself, and it's right there in the palm of your hand.
Because now, the object is real. It's not just an idea anymore, it's a tangible thing. You can hold it, you can turn it over, you can look at it from every single angle. And as you're looking at it, things that were totally hidden in those abstract formulas suddenly just pop, they jump right out at you. You can physically see the symmetry. You can trace with your finger how the edges line up, how the faces mirror each other. Those repeating angles? They're not some rule you have to memorize. They're a pattern you can see with your own two eyes. And this just nails the difference, doesn't it? What can be a super dense, confusing page of equations in a textbook becomes this obvious, intuitive reality when you're holding it. The complex becomes, well, simple. So here's the crucial point. We're physical beings. We are just wired to learn through our senses. Seeing something helps us remember it, for sure. But holding it, that's how we truly understand it. And this doesn't just stop with one shape. Oh no. The power really starts to multiply when you go from a single creation to building an entire collection of ideas. It starts with one, but the curiosity and that little jolt of satisfaction from making the first one, it just pushes you to make another. And then that cycle just repeats itself. You start exploring new variations. Maybe you tackle more complex shapes. Pretty soon, those 2 models become 5. And before you know it, you've got a whole collection going. A shelf starts to fill up, not just with paper objects, but with physical, tangible representations of mathematical concepts. Your collection basically becomes your own private, silent museum of mathematics. Here's your tetrahedron, there's your cube, oh look, an octahedron, a dodecahedron, and a icosahedron. Each one captures a different idea, a different little piece of the mathematical universe. And this is where you start to feel the collective power of these models. As your little museum grows, so does your understanding. It's a process that feeds your curiosity, it builds some incredible patience and skill, and it totally transforms learning from a chore into a genuine, exciting exploration. So, let's bring this all home. What's the ultimate result of this whole hands-on process? It's nothing less than a complete transformation of the subject itself. Physical models do 3 really fundamental things for us. First, the act of creating them builds an intuitive understanding. Second, the finished object demonstrates a truth that anyone can see. And third, having a collection of them lets you physically gather and store knowledge.
What this really does is it yanks mathematics out of the realm of abstract symbols and pure theory, and it drops it right into the world of tangible objects and direct experience. It stops being something you only think about and becomes something you actually do.
And that is the ultimate takeaway. This act of building, of folding and cutting and creating, that's what makes mathematics finally feel and actually become real.
So I'll leave you with this question to think about. If this principle works so powerfully for math, where else could we apply it? What other complex, abstract ideas out there could we finally get our heads around if we just tried to build them with our own two hands?